So first of all, what is dynamic data? So any data in a plot which changes due to some external factor, so whether that's your view window, so plotting and panning and zooming on a plot, changing the data that it is showing, and we'll see some very cool examples about that shortly. Something due to external conditions, so live data updating, or changes due to user input, so interactive plots. These are all things that can cause data to be dynamic when you're plotting. So one of the first things that I want to focus on here is plotting pure functions. This is actually not a great experience in current Matplotlib. I say that as a Matplotlib maintainer. So you often need to know ahead of time the range and resolution that you want to compute. So if I want to plot the sine of 1 over x, it's not hard to do. I select my x values, I select my y values, and I plot. But this doesn't accurately represent that function, now does it? These jagged corners in the lower range here just doesn't represent what that plot is. I can do better. I can increase my resolution, but I still get that. And if I zoom in, it becomes very painfully obvious. So what if I could plot that function as a pure function? So here is that exact function plotted using some of the tools that I have been working on. And I can zoom in infinitely far, and every time we draw, we are actually drawing that function within the view window that we are drawing, that we are looking at. And how do we do this? We do this with an idea that we call containers. So containers are objects that standardize the interface for describing the shape and querying the data. Shapes can be variable. They don't have to be known ahead of time, but they do allow you to compare shapes among arrays that need the same shape, for instance. So your x and y's can both be of shape n. You don't know what n is until you draw, but you know that they're the same. And they're queried at draw time. So the actual code that allows me to plot this function is this little container object that contains x and y, both of shape n. X is literally just returning x, and y is doing the sine of 1 over x. And we can extend this. We can extend this into 2 dimensions. So this is the sine of x times the cosine of y. And similarly to how I could zoom in on that 1D plot, I can pan and zoom all I want on this grid of this function without having to know ahead of time where I was going to plot, without having to know the resolution that I needed to be able to see the detail that I want, without having to pre-compute a million data points. It's actually computing directly at the pixels that are being displayed. And this is a very similar thing, that I get x and y. In this case, because this is an image, I only need the corners of them. I need the upper and lower bounds instead of each individual data point. And then I get the image, which is an n by m array that is computed from x and y. With just a little bit of shape munging in there. But we can get even more complicated than that. A simple sinusoid multiplied together is a little boring. What if we go deeper? We have a Mandelbrot example. And very similarly, the code for this is just get the x and y and then compute the Mandelbrot set. But I can zoom in as far as I want. Get the right zoom tool. And I can keep zooming in to make these small tendrils wherever I so choose. I did not pre-select which region I'm looking at. I can keep zooming in. And each time that we draw, we are getting we are recomputing directly for the region that we're looking at. So we're looking at something that is on the order of 10 to the minus 7th in each dimension here, because I just kept zooming in. And there is a limit where this gets fuzzy because I do not put very high bounds on what level of computation I do. But any Python function can be used for this. You may need a small, slim wrapper to adapt the signature, like we did here. There was an extra parameter for this function that it was defined as, and it actually returned two things, so I needed to select out which thing I wanted to plot. But a small wrapper allows us to plot any arbitrary pure function directly in the window that we are looking at. And we can get more complex computation involved. So here's an example that I have that uses scikit-image to downsample a very dense data set that has 3 levels of detail. So the overall structure is this difference of Gaussians that you may have seen in the Matplotlib documentation many, many times. But if I zoom in, and I can pick anywhere where I zoom, you'll actually see that there's a sinusoidal pattern on top of that I deliberately downsampled to avoid seeing at the high level. And if we keep zooming in, there's actually noise on top of that. And all of this computation is done at draw time with reference to the window that you're looking at. So my next class of data, dynamic data, is live data. So live data is an interesting thing because in Matplotlib it's kind of hard to update your data after you've done it in some cases. We have animations, they get annoying to use, but these data sources allow us to have a real-time data source. This is the actual CPU usage of my computer as I'm presenting right now. And the code for it is right here. So I have a small data class that just gives me a measurement that has 2 fields, time and CPU. Time is a date time, CPU is a floating point value. And then I have a class that has 2 methods. These 2 methods are called describe and query. Describe tells you what you should expect from your data ahead of time without giving you the actual data. So in this case, I have two n-length arrays. So all I really know about these two things is that they are linked together, they have the same shape, and it's a 1D shape. And then in query, we actually take a measurement. So we take a timestamp, we get a CPU usage percentage, we append them to our list of measurements that is capped, and we do a little bit of munging to put them into Matplotlib terms in this example. We call date to num for the date times, and we similarly put them in a list that isn't referencing the original measurement. But these two functions are all that are needed to allow a real-time plot of real-time data. So this could be extended very easily into things like web APIs or other data sources, just by implementing these two functions, or a small wrapper around them that implements these two functions. So in addition to the data containers, which is what enables all of these examples that I've done so far, this work that I've been working on has a flexible system for pipelining information. The core idea is that all information that you want to show on a plot, whether that's your color, your line width, your line style, your marker shape, anything that shows up on a plot can be mapped from initial data. So this is a set of lines that just have various line style mappings and line width mappings, and every bit of information is mapped, and that goes all the way back to position, which is what most people think of, but all of the styling as well. And as a consequence of these mappings, we have taken the coordinate systems that are already part of Matplotlib that you may think about, your data coordinate systems, your axes coordinate systems, your figure coordinate systems. Maybe you think about them, maybe you don't. I don't know. But we have extended those systems and made them more interoperable, more plug-and-play pieces. And a consequence of doing that is, one, we can easily add compatibility layers so that all of these things work on current Matplotlib, and you only need the pieces that you actually need. But two, the artists themselves are separated from their parent. So how many people have tried to plot something and tried to put the same thing in two different plots? And it doesn't work? Well, it can work. So this is a little bit of boilerplate just for compatibility's sake. Setting up two different axes windows. Making one single line object that references a single one of our containers and adding the same line to two different axes. Because the pieces that talk to the different coordinate systems are all separated out such that an individual artist only needs to think about it what it needs to think about. And all of the extra transformations, the transformations from my axes into my figure, etc., are all dynamically able to be requeried at draw time. So we have the same line object in two different axes. I can pan and zoom them independently, but they're the same data. If I make the windows similar, and don't hold my mouse down when I undo a motion, they're the same line. So, how can you go and play with this? This is all on GitHub at MPL DataContainers in the Matplotlib org. It's on PyPI as well as of this morning. And we also have docs. And so what do I want? What I want is to hear from people who might want to use this. People who have dynamic data sources and people who maintain either domain specific or some of the larger projects like Xarray and Xarrays and all of these data sources. How can we better integrate these data stores into Matplotlib using these concepts? And I would like to thank the NASA Roses grant that funded this, as well as my coworkers at Matplotlib, Tom Caswell and Hannah, who did a lot of the theoretical work for a lot of this, a lot of the pure math portion of this, as well as Elliot. I guess I'm at the point where I ask for questions now.
All right. Thanks very much, Kyle. Okay, so I can see various usernames typings, but I had some that I will use, I guess, chair privilege to ask now. Okay, so you mentioned at the very end that this is available both on GitHub under the Matplotlib org and also now on PyPI. So, but this is can you comment, is this something that is like is experimental now and so outside of Matplotlib, and are there plans to bring this into Matplotlib in the future, so maybe the next major release, so that people just automatically get this without having to go install other software?
The current plan is to get the data container side of this, the part that I focus on most for the first half of this, into a state where so the current plan is to get the data containers part of this, the part that was initially the first half of this talk, into a state where users can interact with it very easily within Matplotlib. The mapping side of things is a little bit further behind, but it is used under the hood, but probably the user hooks are a little further behind at least. But yes, it is currently in a third-party library that has a bunch of compatibility layers, but the intent is to make it into Matplotlib.
Okay, great. I'm going to be going through and also selecting questions based off of emoji responses, and so if you see questions that you want, like, you should thumbs them up. So we have a question from Ariana, who is right next to me, so I'll just let her speak it into the mic.
Yeah, I'm really curious if there's practical limitations on the size of data that you can plot while kind of constantly rendering. It looks like someone else had a similar question. So in your experience, what has been the limitation, or can you comment on that?
So for the pure function side of things, you're basically plotting where you're just computing exactly the pixels that you have. So yes, if your function takes a long time, it's dependent on how many pixels you have more than it is dependent on the size of your data, per se, because there isn't a set size of data for the pure function side of things. For some of the downsampling things, yeah, I haven't played too much with scaling that. But there's not actually that much computation, and it's the computation that you want it to have, essentially.
We also have a question from Josh, who says, very cool, and I think we can all agree with that. You did just mention that it just went up on PyPI this morning, but Josh wants to know, is the API you displayed finalized or close to it? He wonders if it would be possible to try and simplify it a little bit more to make it easy for newcomers.
So in terms of the API for things that conform to this, I don't know that there's a whole lot of simplification to be done because it's already relatively simple. In terms of the this example where there's a lot of boilerplate, the main idea is that things that currently work in Matplotlib will continue to work, even if they use this under the hood. There is consideration for the APIs on that side of things, though. But yes, there is a little bit more boilerplate for some of these things. But the key idea is to get it working first.
Yeah, makes sense. All right, we also have a question from Tracy, and they ask, is the dynamic data MD file available for offline review? And I assume what that means is you're showing us this this live off of your local machine, but is this can we find this demo, this talk file on GitHub?
Not yet, but soon.
Okay, that'd be great.
Most of these examples are in the GitHub repo that I did reference. So most of these examples individually are, but the full presentation is not actually on there. Partly because I was installing from a local source and only got it on PyPI this morning, so I want to change that over so that it installs from PyPI.
Yeah, as Dan said, a very proud, SciPy tradition. It's good to be on the bleeding edge. All right, we also have thank you to Lauren for posting the repo in chat. I'm trying to quickly scan for new things. All right, we have a question from Adam. For live plots, do you have any sense of peak data rates that can be visualized while keeping up with the incoming streaming data?
I have not tried too much. It's going to be dependent on how fast your query is, because essentially what you're doing is you're querying at draw time. So this example, this dirty little secret of this example is that under the hood it's using an actual Matplotlib animation, which has a lot of boilerplate to it, but the actual update function from that animation is a no-op. Like, I'm using the animation just to get it to draw more. And so the data rate is going to be very dependent, but if your query is fast, then it's going to be as fast as your query is. But realistically, you only have to, if you're doing this for human consumption, you don't have to update more than, 30 hertz.
Yeah. Okay, we have like 2 minutes left, so I think we can take the final two questions. Tetsuo wanted to know if he wanted to rotate the Earth while using like CartoPy, and then like could we use this to do that?
I think this as a whole, yes. I'm trying to think of which portion of it would actually be, because the mappings actually has a lot that could work well with that. The ideas of different projections and coordinate systems. So that portion of it, which is a little bit further behind and a little bit less user-facing at this point, could enable some of that thing, some of those mapping transforms even more than some of the data side of things.
Okay, so and then we have, I think we have time for one final question. Apologies if I mispronounce your name from Nayan. Any thoughts on how we could embed a dynamic plot into a presentation for an audience? So usually they use Google Slides or PowerPoint. Maybe, yeah, I could imagine that it might be possible if you're giving a talk out of like a Jupyter notebook or something, but.
Yeah, so this talk I originally wanted to make into actual slides, but the slides, when you try to put Matplotlib plots in them, put PNGs in instead, and that doesn't work when the whole point is that I'm panning and zooming. So that is why I did Jupyter notebooks for this talk. If I had a great solution to putting Matplotlib plots into a slide talk, I would have used it.
Okay, great. So we are at time, and we want to make sure that people have enough time to run around to other talks. So let's thank Kyle once more.